A lone cargo ship moves across the dark waters of the Pacific Ocean under a cloudless night sky. Stacked high on its steel deck are thousands of rectangular shipping boxes, silent and heavy against the sea swell. Deep inside one of those sealed boxes, thousands of pounds of fresh produce sit in total darkness. The difference between a fresh harvest and a ruined shipment depends entirely on an invisible line of cold air. Inside that insulated reefer container, a dedicated refrigeration unit runs continuously to push icy air through tiny floor grooves. Cold air must flow around every crate, keeping the internal environment within a tight margin of half a degree. If the air circulation stops or the temperature drifts even slightly higher, microbiological decay begins almost instantly. What looks like a static metal box is actually a delicate environmental battleground floating across the ocean. For decades, global shipping relied on blind trust and basic mechanical thermostats that offered no warnings when things went wrong. Ships would sail for 3 weeks with zero communication about the condition of the cargo sealed inside the hold. Crews only discovered cooling failures when workers unbolted the container doors at the destination port, welcoming toxic heat and spoiled goods. Millions of dollars in ruined food were written off as the cost of doing business across vast distances. A single hidden power failure or clogged cooling coil on the open water meant total financial ruin for regional farmers. Entire harvests of delicate berries, fresh beef, and tropical fruits turned to mush long before reaching store shelves. Beyond the massive economic loss lay a deeper problem of wasted resources, fuel, and labor. Without real-time visibility into internal conditions, ocean transport remained a risky gamble against heat, time, and mechanical failure. The arrival of active smart logging technology transformed these passive ocean boxes into connected digital outposts. Engineers integrated specialized cooling controls directly into reefer containers, pairing heavy diesel generators with sensitive digital instruments. Instead of remaining isolated islands of steel, the containers began recording their own internal vital signs every few minutes. This engineering leap marked the beginning of a modern cold chain driven by active data rather than hope. At the heart of this protection system sits the compact IoT data logger. Mounted inside the structural framing of the reefer, packed with low-power sensor arrays, these hardened devices measure ambient air temperature, relative humidity, and physical vibration. Tiny probes extend into the air supply ducts to ensure the cooling system delivers exact thermal conditions. Every single data point is saved locally on solid-state memory chips designed to survive harsh ocean environments. These intelligent loggers do far more than collect numbers in silence because they actively broadcast real-time status reports. Integrated cellular chips connect to land towers whenever a cargo ship sails near coastline ports or freight terminals. Far out at sea, low Earth orbit satellite modems take over, beaming location coordinates and thermal readings directly into global computer networks. Disruption in power or temperature triggers an immediate digital alarm long before cargo begins to rot. Logistics teams working thousands of miles away can monitor the exact condition of a single box in real time. If an internal sensor detects a dangerous rise in humidity, operators on land receive an urgent alert on their screens. They can contact the ship engineer to clear a blocked air vent or restart a stalled compressor unit mid-voyage. Problems that used to remain hidden for weeks are now caught and corrected within minutes of happening. The open sea presents brutal physical forces that constantly test the limits of sensitive sensor hardware. Extreme heat on deck, heavy saltwater spray, and constant engine vibration can easily ruin basic consumer electronics. Engineers build IoT data loggers inside waterproof cases, shielded against electromagnetic noise from ship generators. These rugged devices must operate reliably across frozen Arctic seas and scorching desert ports without losing a single line of temperature data. Advanced loggers also track physical shocks and unexpected door openings using sensitive multi-axis accelerometers and light sensors. If a container drops hard during crane loading, the sudden impact is recorded with an accurate timestamp and location marker. If unauthorized personnel break a door seal in transit, Light sensors register the intrusion and flag the breach. Every physical event along the journey creates an unalterable digital footprint that assigns clear accountability. This continuous stream of sensor data fundamentally shifts cold chain management from reactive panic to predictive maintenance. Modern software analyzes compressor power draw and air temperature differentials to spot mechanical wear before parts break down completely. If a cooling fan starts drawing extra electrical current, the system schedules maintenance at the next port before complete failure occurs. Prevention replaces repair, keeping valuable cargo safe through thousands of ocean miles. The critical importance of active cold chain monitoring extends far beyond the global food market into human healthcare. Temperature-sensitive biological products like life-saving vaccines, insulin, and blood plasma require flawless thermal stability to remain effective. A slight temperature spike during shipping can destroy the molecular integrity of medical supplies without changing their physical appearance. For these delicate biological goods, active IoT monitoring is a literal matter of human life and safety. When a container carrying clinical vaccines strays outside its safe storage range, automated alarms alert distribution managers immediately. If the temperature variation cannot be corrected in time, safety protocols prevent spoiled medicines from reaching patients. The recorded temperature logs serve as legal proof of thermal compliance required by government health agencies around the world. Without reliable IoT data loggers, safe global distribution of advanced medicine would be practically impossible. Designing electronics that run continuously for weeks without external shore power requires clever hardware engineering. IoT loggers use low-power microcontrollers that sleep between sensor reads, consuming mere microamps of electrical current. Specialized long-life lithium batteries keep the internal sensors and wireless chips operating even if the main reefer unit loses power. This backup energy source guarantees that critical logging continues even during power outages on train cars or dockyards. Massive ocean carriers and logistics providers pool millions of sensor data points into global cloud analytics engines. Machine learning models process historical temperature trends, weather forecasts, and shipping routes to predict thermal risks across complex supply lines. Logistics algorithms suggest faster shipping routes or identify unreliable dock facilities based on sensor records from past voyages. The entire global shipping grid learns and improves from the collective intelligence of individual data loggers. The transfer of reefer containers between cargo ships, freight trains, and long-haul diesel trucks creates major logistical handoffs. In the past, responsibility for cargo damage was contested between shipping lines, port operators, and trucking fleets. IoT loggers solve these legal disputes by establishing an unbroken, time-stamped record of thermal and physical conditions. Insurance companies rely on this precise data to determine exactly when and where cargo damage occurred. When reefer trucks travel through remote mountain passes or deep ocean dead zones, wireless communication links can drop out completely. During these communication blackouts, onboard solid-state storage chips record every sensor reading locally at fixed time intervals. As soon as the container enters cellular or satellite coverage again, the data logger automatically uploads its cached records to the cloud. No information is ever lost, ensuring a complete and unbroken thermal record from origin to destination. Traditional border crossings and port customs procedures used to cause long delays that threatened perishable freight. Customs inspectors had to open container doors physically to take manual temperature readings, letting cold air escape in tropical heat. Today, customs officials can read verified digital logs wirelessly through sealed doors without disrupting the internal cooling environment. Cargo moves through port terminals much faster while preserving optimal storage conditions inside every box. The combination of active smart reefer boxes and real-time IoT logging creates unprecedented transparency across global commerce. Buyers and sellers can track high-value perishable shipments on interactive maps, verifying safety conditions at every stage of transport. Automated smart contracts can even release payment automatically once the sensor log confirms safe arrival within mandated thermal limits. Trust is built into the digital record itself, eliminating financial friction between international trading partners. Reducing global food loss through smarter logistics is one of the most effective ways to preserve natural resources. Millions of tons of fresh food are wasted every year simply because refrigeration systems fail somewhere along the supply chain. IoT-monitored reefers prevent massive food loss, ensuring that farm yields reach consumers instead of ending up in landfills. Efficient cold chains stretch local food supplies across global markets while lowering the environmental impact of trade. Standing on a bustling port dock, one watches hundreds of reefer containers loaded onto massive ocean vessels every hour. Inside those humble corrugated steel boxes, an invisible web of microchips, sensors, and wireless transmitters works without pause. They hum quietly in the ocean dark, guarding fresh food and vital medicines against extreme weather and mechanical failure. This quiet technological miracle transforms wild ocean journeys into reliable, life-sustaining channels of global supply. As global trade networks expand and climate conditions become more unpredictable, the need for smart logistics hardware will only grow. Future reefer containers will integrate even smaller sensors, longer battery life, and faster satellite uplinks to track every variable of freight health. The shift from passive ocean containers to active, smart logistics units stands as a triumph of modern industrial engineering. Through continuous digital surveillance, the global cold chain keeps our modern world fed, healthy, and connected.